This section of the notes is going to be dealing with rocks. So you've already seen videos dealing with minerals and mineral identification. And we said when we came around elements and compounds and mixtures that elements and compounds are pure substances. And those pure substances are usually what makes up minerals, because minerals, in order for a mineral to be a mineral, it's got to meet 4 specific characteristics. With rocks, rocks are pretty much a mixture. So you have a bunch of minerals mixed with other types of rock, mixed with maybe organic material, which you couldn't have as a mineral, that make up rocks. So rocks are kind of that catch-all for everything else that deals with the surface of the earth, or what makes up the surface of the earth. So just like we talked about with water cycle back in meteorology, and just like you talked in chemistry last year about solids versus liquids versus gases, each of these make this pattern sequence where change can take place if the conditions are right. So for example, with a solid, liquid, and gas, if I heat up a solid enough, I can melt it and turn it into a liquid. If I heat it up even more, I can turn that liquid into a gas. If the conditions are right, which in that case would be temperature, then the state of matter changes from a solid to a liquid to a gas. In the water cycle, same type of idea. If I have enough of the sun's radiation, I can make water, liquid water on the surface turn to water vapor. Cool down enough, the absence of heat can actually cause that water vapor turn back to a liquid. So if the conditions are correct, I can change from a solid to a liquid to a gas, or even change states of the water cycle from evaporation to condensation, condensation, precipitation, and so on and so forth. Those are cyclical patterns, or cycles, and they're mapped out that's tough to say, cyclically, because you can change, if conditions are right, you can change matter from one state to another, one type of matter to another. Rocks have that same type of characteristic. They go through what's called a rock cycle. So what's up on screen right now is an example of a rock cycle. And if conditions are right, a rock can change from an igneous rock to a sedimentary rock to a metamorphic rock, which are the 3 types of rocks: igneous, sedimentary, metamorphic, or vice versa. So the arrows in this graph indicate the different types of conditions that are needed. Now, it's just an overview. Those aren't the exact conditions, because for example, with sedimentary rocks, yes, weathering and erosion will break down older types of rocks or parent types of rock. However, there's still other parts of the process. So the arrows are indicating this is the start of each of the changes, and once conditions are met, one rock can change into another. So igneous rocks can change into a metamorphic rock or a sedimentary rock if the conditions are right. So in the next slides, we're going to talk about what makes up an igneous rock, their characteristics, why there are 3 different types of rocks, but we're also going to get into what conditions are needed to go from one rock to the other. You're going to be filling in a graphic organizer as we do this, so that sheet has been given to you separately. In these notes, though, I did make pictures of the completed chart, so if you're having trouble filling in the graphic organizer as we talk about it, then we will do it together through this video. So we're starting with igneous rocks, and igneous rocks are one of the 3 types of rocks you can find on the surface of the earth. Each type of rock has specific characteristics, also tough to say, that make it the type of rock it is. But usually the characteristics have to indicate on how it forms. And igneous rocks, like we said in the rock cycle picture, can change and turn into sedimentary or turn into metamorphic if conditions are right. Igneous rocks have distinct characteristics that are only describe igneous rocks. So you'll see that as we talk about different types of composition and different types of texture. But let's talk about what makes an igneous rock an igneous rock. So an igneous rock is a rock that once was magma or lava, and that's liquid rock, and liquid rock is a type of one of the 3 types of rocks, but that liquid rock cooled, solidified, hardened, and became what we call an igneous rock. So a rock can become an igneous rock if it melts and rehardens. No matter what it was before it melted, if a rock melts and hardens from either the heat inside the earth, the heat on the surface, or even in a man-made laboratory, if you can get a oven to heat up to about 2,000, 3,000 degrees centigrade or Celsius, no matter what the rock was before, if it melts and rehardens, it's automatically considered an igneous rock. So a lot of times we give the example of an igneous rock from volcanic eruptions. So either lava on the surface or magma within the earth. That's why there's two different names there. Magma is molten rock that's inside the earth, and lava is what you see at the result of a volcanic eruption when that molten rock comes onto the surface. Now, they're given two different names because they're found in two different locations. Magma is found inside the earth. So that's going to create different types of igneous rock. Lava is on the surface of the earth. Now, lava on the surface is going to be exposed to a huge change in temperature. Inside the earth, the rock layers act like an insulating blanket and will keep rock hot because there's, for millions of years, there's been heat inside the earth that just hasn't all escaped out into space yet. For the last 4.5 billion years that the earth has been formed. And the rock layers act like pretty much an insulation blanket. So stuff inside the earth cools very slowly, and that magma cools very slowly. What that allows, it allows those minerals that make up those rocks to actually form and form crystals, and those crystals get bigger and bigger and bigger. On the surface, though, you're talking about a difference of temperature between 3,000 degrees Celsius and, let's say, 40 degrees Celsius. Let's say even the hottest of days. Let's say we're talking about Hawaii. Okay, maybe 30 degrees Celsius. So because you have such a dramatic change in temperature, rocks on the surface, a molten rock on the surface, will cool and harden very quickly because it's such a dramatic change in temperature. So lava is usually the type of molten rock that will cool very quickly, and it doesn't allow those minerals inside time to grow. We're going to talk about how that creates two different types of igneous rock. So the word igneous means fire. It's a way to remember it. Again, once a rock melts and turns into magma, that magma cools, becomes an igneous rock, or lava. Igneous rock is classified according to its composition and to its texture. But what I wanted to make sure that you understood was the difference between magma and lava, the reason why they're in two different locations. Because they're going to create two different types of igneous rock. Now, what do we mean by texture and composition of igneous rocks? What makes them up is composition. Texture is how they look. Usually we think of texture as how something feels. In this case with rocks, texture is part of the makeup of it, kind of what it looks like. So there's two different types of igneous rocks. There's the coarse-grained and the fine-grained. Coarse means large, which means the minerals inside are extremely large. I don't have any samples to give you right now, but just take my word for it. So inside, the mineral crystals that make up this rock are very large. Why? Because they had time to grow, because these types of rocks are forming inside the earth where the change in temperature is so gradual, so slow, that it allows those crystals time to get bigger and bigger and bigger. Now, there's an object in your house, maybe, but I know it's used as a building material called granite. Granite is an igneous rock, and a lot of the reason why people love to put granite in their house, in their bathrooms or kitchens, what have you, as countertops, because the patterns that the mineral crystals make inside the rock. If the rock is forming deep inside the earth, there's a lot of time for those crystals to grow and form, and that's why with a slab of granite you have to use from the same slab because it was formed at the same time. You can't mix and match pieces of granite to make them look alike because no two pieces of granite are usually made the same. Those granite crystals have time to grow depending on their location. Fine grain usually indicates, it means small crystals or crystals that you can't see. That's what fine means. It just means small or minute, whatever you want to call it. So fine-grained crystals are usually created when the rock is cooling extremely quickly, and that happens on the surface of the earth when the air or the water come in contact with molten lava. So rocks that were once lava are usually considered fine-grained when they harden and they cool. So coarse-grained is large crystals, fine-grained is small crystals. We call different types of igneous rocks felsic and mafic. Felsic is similar to the granitic, granite type of rocks, where you have lighter color and low in density. A good example of a felsic rock is pumice. Okay, if you use, let's say, a skin defoliation thing, there's lava soap out there that has pumice that's mixed into the soap itself. It's this very gritty but very light and low density type of rock that actually floats on water if you actually put it in water. That's how you know you have true pumice. That's a felsic rock. That's one that was formed on the surface from lava, and what happens is the lava created bubbles within the rock, and those bubbles popped and left those grooves and crevices inside the rock. So felsic rocks are ones that are kind of low in density because they have a lot of air pockets to them. Mafic rocks are also called basaltic, which are more dense rocks. Okay, we're going to talk about the difference between granite and basalt another time. But basaltic rocks are mafic, and mafic rocks are darker and denser. Obsidian is a great example of a darker and denser rock. So what I might do, when I'm thinking about doing this, is I might actually have to make a separate video where I show you the different types of rocks, so you at least see the different samples of it. But for now, just know that mafic means darker and more dense, felsic means lighter and less dense. Coarse grain is large crystals, fine grain is small crystals. Now, because of where they form, igneous rocks have two classifications. They can either be considered intrusive or extrusive. And these seem like big words, but they're really not. Intrusive, think of the prefix INT. You have a marker here. This prefix INT. Think of the word interior and what that word means. Interior means inside. So if you're talking about the interior of your home, you're talking about the inside of your home. EXT, think of the word exterior. So these are prefixes that refer to something specific. The exterior of your home is what's on the outside, your landscaping, your grass, your siding, whatever. So therefore, knowing those prefixes that INT means in and EXT means out, you've got two different types of igneous rocks. Intrusive rocks are those that are formed inside the earth. Extrusive rocks are formed outside of the earth. So that right there gives you kind of an idea, because they cool and they harden at different rates. One does it quickly, one does it slowly. It gives you different types of igneous rocks. So intrusive rocks are those that are formed inside the earth, and extrusive ones that are formed on top of the earth. So now you kind of have a classification between magma and lava. Intrusive rocks, as it says here on the next slide here, it just basically says that intrusive rocks are formed from magma. Magma is inside the earth, so therefore all intrusive rocks, like granite, would be considered magma rocks. They once came from magma. All right, they're usually coarse grained. Why? Because they have so much time to form those crystals. Those crystals have so much time to develop inside the earth that that cools very slowly, allows them to grow. So, like I said, granite is a great example of an intrusive igneous rock. Okay, there's some other rock formations. I do have a picture on the next slide, which I'm not going to get too crazy into. But what I want you to know from this is intrusive means inside, interior of the earth, inside the earth, and magma comes from inside the earth. So which means igneous rocks that came from magma are automatically considered intrusive. Usually very coarse-grained, large crystals that make them up. Like I said, granite's a great example of that. These are some other intrusive rock layers that I don't need you to memorize. I just want to show them to you. Sometimes the heat of the earth can melt away existing rock layers. So you kind of see the border up here, and it kind of reached up here, and it kind of melted away the existing layered rock that made up the earth. Well, here's the thing. When a rock melts and rehardens, it's automatically considered a brand new rock. So it actually changes the age of these rocks. So these rocks are actually younger, the ones that are in the picture here, than the existing layers. Like here are the layers. Okay, another layer on top of another. So the rocks that are forming here are actually younger than the ones that are already existing because they were melted, molten rock, and then they became igneous. A lot of times you get your granite and your basalt you can get from these inner, well, granite more often than not, the basalt, inside the earth when they get uplifted onto the surface. So the other type of igneous rock is the extrusive rock. Now extrusive, like we said, EXT means exterior, rocks that form on the surface of the earth, which means these are the ones that are coming in contact with the Earth's atmosphere or the Earth's water, and it's cooling them very quickly. These types of igneous rocks, unlike intrusive, cool very quickly, so because they're more fine-grained. All right, so extrusive igneous rocks are fine-grained. Obsidian, pumice are great examples of that. So now that we have talked about igneous rocks, and we're going to kind of move on into the other types of rocks, here, take a minute and you can pause the video to fill in your graphic organizer. I'm just going to briefly talk through it. Igneous rocks, so the first column here, is formed by the hardening of magma or lava. Magma inside the earth, lava on the outside of the earth. There are two types of igneous rocks, intrusive rocks and extrusive rocks. Intrusive rocks are formed in the Earth's crust from magma. The minerals are coarse-grained, large, because minerals have time to grow because the change in temperature is gradual. A great example of that type of rock is granite, like we talked about.
On the other side of that column is extrusive igneous rocks, which form on the surface of Earth from lava. These minerals are fine-grained because the minerals don't have time to grow because the change in temperature is drastic. It's very quick. So there's two types of those. You got felsic and you got mafic. Felsic being the light color, low density. Pumice being an example of that. And then mafic rocks, which are dark, high in density. Basalt is a great example. Obsidian is a great example. So this is how you can fill in this left side of the chart. So you have a graphic organizer to kind of organize your thinking with all of these different characteristics of just this one type of rock. As we talk about the other two types of rocks, we'll fill in the rest of this chart. So the next type of rock we're going to talk about is these sedimentary rocks. Now, igneous rocks are formed from molten rock that is cooled and hardened. Sedimentary rocks, though, were once other types of rocks that have been broken down into smaller and smaller pieces. We call those smaller pieces sediment. Okay? So what breaks down rocks is usually two processes that are called weathering and erosion. Usually weathering and erosion are words that are interchanged. Erosion usually means, yeah, it's broken down, but then it's carried somewhere else. So when a river wears away the side of a riverbank, the current of the river will take those little pieces of sediment and carry it down the river and place it somewhere else. That's a good example of erosion. Weathering is just the breakdown of a rock. It might be in the same spot, and the rock over time just breaks up into small different pieces. Okay? So rocks that are made of pieces of other rocks considered sediment are considered sedimentary rocks. So think of sand. If you go to the beach and you walk in the sand, all those little grains of sand at your feet are considered sediment. You go to, let's say you're in your garden in your house, all right, around your house, the exterior of your house, and you're in the garden and you're playing with the soil or you're digging to put plants in there. Well, those pieces of soil and dirt that you're digging through is considered sediment. So imagine if all of those hundreds, thousands of pieces of sediment formed together and create a brand new rock. That's what a sedimentary rock is. It's basically a makeup of other rocks that have broken down, weathered, eroded over time. So rocks make up pieces of other rocks, which is sediment. Weathering and erosion will wear those pieces. Again, weathering is breaking up the rock. Erosion is also doing it, but it's also carrying it somewhere else. Now, what causes rocks to break up? Wind, water, ice, because you get ice in these cracks and then expands the crack and then the ice melts away and the rock breaks into from bigger pieces to smaller pieces. Okay, that's what I want you to think of. I want you to think of an existing rock that's large, that's being broken down into small pieces, like sand, like soil, like dirt, like gravel. Great examples. Sunlight can do that when it heats up ice and changes to, liquid water and melts it away, or even evaporates the water away. Gravity, let's say you're at the side of a cliff and the wind comes through and pushes a piece of sediment off the big parent rock that's there. Well, that will drop, gravity will drop it down to the earth and it will form somewhere else. So these are all ways weathering and erosion can take place. But just remember the difference. Weathering is just the breakdown of rock in one location, stays in the same location. Like soil will form this way, and we'll talk about that when we get to soil. Erosion is like a riverbank where they'll basically take it and put the sediment somewhere else. And then over time, the sediment will layer up, and from that layering is where you're going to get a new rock, a new sedimentary rock. Rocks like sandstone, siltstone, silt is a type of sediment, are good examples of that. If you dig in your yard now, if you go like maybe 2 feet, 3 feet down in your yard, you're going to come across shale. Shale is a sedimentary rock. If you think a little bit about the Earth itself, when we talked about in astronomy about the Earth forming, and all those dust and gas pieces formed together and came closer and closer and closer and formed into this one large ball of rock, technically the Earth is one big sedimentary rock formed in the same way. So we'll talk about that in the next slide. So weathering and erosion will wear away a larger chunk of rock, turning the larger chunk of rock into a smaller piece of rock. After that weathering or erosion takes place, the sediment which is left over can get transported to other places. The big part of this is going to be where does it get deposited, like put. Where a deposit just means put. A bank. You can either withdraw or deposit money in a bank. Deposit means you're putting the money in the bank. Sediment gets deposited, put somewhere, and sometimes it gets deposited into layers. So when you've got a river and it's pulling the sediment away from the side of the river and transporting it somewhere else, sometimes that sediment will basically layer up. Okay, it's that layering process which is going to create the next type of rock. So like I was saying, deposition. Definition for deposition, which is one of your key terms, the putting down or placing of sediment, soil or rock, which can get added to a larger piece of rock, a larger chunk of rock, a land mass of some sort. Now, once the rock is deposited, the weight of the top layer, gravity will pull down the top layer and push down those layers of rock so that the top layer gets pushed down towards the bottom layer. That pushing is called compaction. The layers are being compacted and compressed into those layers. Well, that layering, that compaction, can actually cause those rock pieces to actually form together. And when they do, they create what's called this natural glue, or this cement. I almost said sediment. Okay, this cement. That cement is actually what allows the rocks to start to form together and become a brand new sedimentary rock. So a sedimentary rock was once part with all these different pieces of all these different rocks from all these other different porous rocks that got eroded away, worn away. They deposit in the layers. That deposition will then compact these pieces together and become a brand new rock. And all the natural sediment or cement, again, that cement that forms inside actually creates a brand new rock. So a sedimentary rock is created from existing rocks. Now, think about it this way. Weathering and erosion takes place at the surface. So sedimentary rocks are usually formed at the surface. Other types of rocks we're going to talk about are usually formed within the earth, and with lava and magma being igneous, it could be both. It could be on top of the earth or it could be inside the earth. That melts the rock and forms a brand new igneous rock. Metamorphic, which is the third type of rock we're going to talk about soon, forms deep inside the earth. So just to kind of recap sedimentary rocks, you have a pre-existing rock of some sort, a parent rock we call it. The pre-existing rock is weathered and eroded, it's broken down, maybe some of the pieces are carried somewhere else. All that sediment that's left over is then layered, deposited into layers, so deposition takes place, and then those layers start to weigh on top of each other and start to compact and cement themselves together. From there you have a brand new rock. Now what will happen is the rock will form into layers. Okay, so sedimentary rock is usually very layered. Sandstone's a great example that you see the different colors of sand in a piece of sandstone. Like I said, I'm going to try and do another video where I show you all of those. Those layers, again, make up that natural cement, but those layers are called strata. So on the next slide here, I have some examples of strata. Okay, the layering of rock. You can see the picture on the left. So I see all the different layers I'm drawing here. You could see a picture of the rocks like this. Let's say you go up towards the Poconos or up towards upstate New York, and you're on the Northeast Extension. Look at the side of the road. They cut through mountains to make that roadway. You can see the side of the mountains. Now, the strata doesn't always look nice, straight, level, and parallel. Sometimes they're slanted or tilted. If you go out to the west and go to the deserts of the west, you can kind of see the different strata lines from the wind-blown cliffs of these rock formations. You see all those different types of strata. Strata just means layers. So if you come across the word strata, it just means layers. So sedimentary rocks are classified in 3 different classes. Okay, the first class is called, well, let me bring this up. It's called clastic or detrital. So I'll give you an example. I'll show you a picture of that in a second. The second category is called chemical sedimentary rocks, and then the third is called organic sedimentary rocks. In minerals, we said that minerals can't have organic matter made of them, that way they're not a mineral. However, in a sedimentary rock, let's say you have, let's say plant imprints, or let's say shell imprints, or maybe even bone that mixed in with rock. And if you find a piece of, let's say, limestone, and it's got shell imprints and shell pieces, or it's got bone imprints, or it's got leaf imprints, whatever, those are things of life that are now forming along with sedimentary rock, and were bonded together at the same time as the pieces of sediment were bonded together. So that's what makes a third type of class of sedimentary rock. So we start with the first type, which is called clastic or detrital. This is just sediment that gets bonded together with other pieces of sediment, and a natural cement is formed. So sandstone is a great example on the right-hand side here. Here's sandstone, all those pieces of sand, okay, mixed together, that make another new type of rock. Down here is a conglomerate. These are all bigger pieces of gravel and rock, and the natural cement you can kind of see between. That's what cement is. When you go out to see your sidewalk, that's pretty much a sedimentary rock. It was bonded together, all these different pieces of gravel that they glued together and bonded together and pushed down together. The roadways are great examples of sedimentary rock. It's all oil and asphalt, and they kind of bonded it together so that cars could drive on a nice flat surface. These are all good examples of clastic, or what's also called detrital, types of sedimentary rocks. Another type of classification is the chemical sedimentary rocks. So last year you learned about solutions from minerals and water. When the water evaporates, all you're left with is the kind of sediment that's left over from when these bond together. Excuse the bell in the background. Okay, so chemical sedimentary rocks are kind of that leftover pieces. Limestone is formed this way, and it's just a mixture, a bondage of minerals and water. Water once was here, and it made that limestone. So it's a solution, which is the chemical mixture that you talked about in chemistry last year. The last type is what I was kind of giving you an example of when you have organic matter mixing with ordinary sediment rocks, sand, gravel, whatever. That type of rock that's formed can be considered what's called an organic sedimentary rock. So it forms remains of dead plants and animals plus the rock itself. So this is a good example of organic limestone in the picture here. So before we get back to the graphic organizer, I just want to introduce coal to you because I know one of the questions on your weekly pyramid is going to ask, what is coal? Coal is an organic sedimentary rock, but there are types of coal that are considered metamorphic, depending on what type of coal we're talking about, anthracite, bituminous. It doesn't matter. But think about what coal is. Coal is a fossil fuel. Coal is almost like basically an organic sedimentary rock, just for the fact that it's remains of once living plants and animals. In this case, with coal, it's plants, what we call peat. Okay, plants and swamps would basically form and die on the surface, on the bottom, of a lake or a swamp or whatever. Well, over time, they would get compressed and pushed downward in layers and downward and downward and downward to the point where over about 1 million years would take place, and this peat that was once plants and animals make up this organic sedimentary rock called coal. Coal's used to burn, for heat. That's why when you in Pennsylvania go to a coal mine tour, it's deep inside the earth because coal was formed, on the surface at first, but then was pressed down, and all that pressure created that rock to form. Over 1 million years of pressure actually caused it to form. So that's what coal is. Coal is actually a fossil fuel that we've talked about in energy. However, it's formed as it's actually technically an organic sedimentary rock. So let's go to your chart, let's go to your graphic organizer and fill in the middle column. So we just talked about sedimentary rocks. So your igneous stuff is still there. Sedimentary rocks is now your next section. Let me read through this real quick. Again, there's going to be background noise because classes are coming, but I just ignore those. Okay, sedimentary rock is this first one. It is formed by weathering and erosion. The rock layer is then deposited into layers. So all those pieces of sediment are deposited into layers, and then those layers are then compacted and cemented. This might be tough to see, and again, you may have to pause, but those are the words, and I gave you a word bank too. 3 types of sedimentary rocks. The clastic detrital, which is down here, okay, clastic detrital, an example made of rocks and minerals. An example of that would be sandstone. The next type is called chemical. Chemical are the minerals of, solutions of minerals and water. So in order for these types of rocks to form, water had to have existed. So good question would be, hey, Pennsylvania has a huge limestone deposit. What does that give you to the history? What does that tell you about the history of Pennsylvania? That it once was underwater. Organic is another one of those sedimentary rocks we talked about. Coal being a good example. Certain types of coal being a good example of that. Organic sedimentary rock that is made of remains of plants and animals along with the sediment pieces. So that's a good example of, that's the overview, the graphic orienters of sedimentary rocks, kind of taking all that information and organizing it into kind of one chart there. Finally, the last type of rock we're going to be talking about is metamorphic rocks. And this is not as detailed as sedimentary or igneous. Metamorphic rocks are rocks that are found inside the earth. And what happens to the minerals inside the rock is they go through chemical changes. You learned in chemistry in 7th grade that a chemical change is when one type of substance basically turns into another type of substance when the conditions are right. The conditions needed for minerals to change from one substance to another is heat and pressure. Inside the earth, there's immense amount of heat, and if you're going under hundreds of layers of rock, poundage of rock, you're going to get the pressure. So heat and pressure will cause changes in rocks and changing the minerals from a sedimentary rock, from an igneous rock, turning them into a metamorphic rock. So metamorphic means change, means metamorphosis. It's the same thing as change. Butterflies, when they're worms or caterpillars, not worms, they're caterpillars that go through a metamorphosis and become butterflies. That means change. Metamorphic rocks are rocks that were once maybe sedimentary, maybe once they were igneous. They go through a change, their minerals go through a change, and they become metamorphic. So there's other ways rocks can melt. Okay, they can melt in 3 different ways. We're just going to talk about, be exposed by immense amount of pressure. There's 2 different types of metamorphism that I'm getting into here. One, if the rock itself comes in contact with magma, but that contact with the heat causes the mineral to change, but the rock itself does not melt, that is considered contact metamorphism. So inside the rock layers, you saw the different rock layers that got melted away, but what about those layers around it? Maybe they're not sedimentary anymore. Maybe they're metamorphic because it came in contact with magma, but the minerals changed their chemical composition, but the thing didn't melt itself. If it had melted, it's automatically igneous. If the change takes place, but no melting takes place, it's considered a metamorphic rock. That rock can be considered a metamorphic rock. So that's called contact metamorphism, when rocks come in contact with the magma or lava, but they don't melt. Regional metamorphism is the pressure side of it. When you've got rocks that are deep inside the earth under hundreds of pounds of pressure from the rocks above, or if, let's say, when plates move, as we're going to talk about in earthquakes later on, when they come in contact with each other, and that contact with each other actually causes the rocks to change, that is a different type of metamorphism. It's called regional metamorphism. So you have contact metamorphism and regional metamorphism. Now, I am using a lot of big words, and if you're not understanding this, that's okay. That's why I give you the graphic organizer, just organize your thinking. Use that as your kind of your guide. The last thing I want to talk about is texture, the way they look. So sometimes people will put metamorphic rocks in their house, just like granite, where they have awesome pattern to them. They're nice to look at. Churches will use metamorphic rock, absolute for their patterns and because of the material itself. A lot of sculptors use metamorphic rock because it was malleable. They were able to carve out awesome sculptures with it. Well, the one I'm thinking in my head example is marble. Okay, you may have marble countertops. You may have a marble floor. You may have marble around your fireplace. Though that's a type of metamorphic rock, and it might have a nice pattern to it. It might be considered a foliated metamorphic rock, or marble, foliated metamorphic rock. Foliated means the minerals are aligning themselves in a certain type of pattern. That's why people like marble in their house or in their bathrooms, because it actually looks pretty. So it makes a pattern. Those patterns are called foliated metamorphic rocks. If the metamorphic rock does not make a pattern, then it's considered non-foliated. The other example of a metamorphic rock I can give you is a chalkboard. Chalkboard's called slate. Slate's what makes up chalkboards. I don't have one in my room anymore. I used to have one in my old room, so I used to point to it and say, that's a big piece of metamorphic rock. Okay, but I don't have it anymore. But I'll show examples, like I said, in that other video that I create, whenever that's going to be. So non-foliated rocks are those that don't have a pattern. So it's just 2 ways to know a different type of metamorphic rock. If the rock has a pattern, it's foliated. If it doesn't have a pattern in it, it's not foliated. So I'm going to go back to the chart, the graphic organizer, and the last thing we're going to cover, but you can fill in the rest of the chart on the next slide. So here is the rest of the graphic organizer filled in. And again, I will read like I did before. Metamorphic rocks are caused by heat and pressure. Okay? Heat and pressure will cause that chemical change to take place in the mineral of the rocks, but as long as they don't melt, because if they melt, then they're over here at the igneous side. 2 types of metamorphisms, contact metamorphism and regional metamorphism, and there's their definitions, just like you had in the last slides. And then, of course, 2 types of textures that happen with metamorphic rocks. You've got the foliated, which means the minerals align a pattern, and the non-foliated when they don't align a pattern. So that's it for rocks. The 3 types of rocks, how they form and how they're classified. Excuse the bell again. Okay, so this is the sheet I want you to use, this one right here. Okay, this sheet I want you to use for your studying of the different types of rocks as we move forward. And then we're going to move into how these rocks make up our entire structure.